In this video, you will learn about polygons. Now, what is a polygon? Well, if you look at the word polygon, we have the prefix poly, and then the last part, gon. Poly means many, and then gon is Latin for angle. So the word polygon literally means many angles. So what we have are shapes that have many angles in them. So more specifically, these shapes are going to have straight sides. These shapes will be closed, and these shapes will not cross over itself. So here we see three different examples, where with each polygon, we have straight sides. Each of these shapes are closed, and notice nothing crosses over itself. Whereas here, these are not polygons. This first shape is not a polygon because this side is curved, it's not straight. The second shape is not a polygon because it crosses over itself. Okay, because it crosses over right here, okay, this would not be a polygon. And this third shape over here has this big opening. So because of that, this shape is not a polygon. Now with polygons, there are different types of polygons. First, we have convex polygons. A convex polygon is where no line containing a side of the polygon contains a point in the interior of the polygon. So for example, something like this. Now this definition might be a little vague and kind of difficult to understand. It might be easier to understand convex polygon by looking at the opposite. The opposite of a convex polygon would be a concave polygon. So that would look something like this. Alright, notice a concave polygon is caved in right here. Alright, so a concave polygon says that at least one line containing a side of the polygon contains a point in the interior of the polygon. So this point right here is on the interior of the polygon. So just imagine this as being a cave. Alright, concave will look like it has a cave in it, whereas convex does not have that. Alright, so make sure you know the difference between a convex and a concave polygon. There are different ways we can categorize polygons, so this is one way. Another way is by the number of sides. If a polygon has 3 sides, we call that a triangle. 4 sides, we call it a quadrilateral. A 5-sided polygon is a pentagon. 6 sides is a hexagon. 7 sides is a heptagon. 8 sides is an octagon. 9 sides is a nonagon. 10 sides is a decagon. 11 sides would be a hendecagon. And 12 sides would be a dodecagon. Alright, so make sure you know these different terms. The 11-sided polygon, for some reason, is usually not mentioned or discussed much when you're working in geometry, but this is the term we give to an 11-sided polygon. So what do these look like? Well, here we see all these different shapes. So quadrilateral has 4 sides. Here we have 5 sides, 6 sides, 7, 8, 9, 10, and then 12 sides. So these are what the shapes would look like. Now we have what is called regular polygons. Regular polygons are polygons that are equilateral and equiangular, meaning the sides are all the same and the angles are all the same. So looking at this quadrilateral, this would be a square because every side is the same and every angle in this case would be 90 degrees. Same thing with a regular pentagon. Every side is the same and then each angle inside is the same also. That goes for all of these different shapes. Alright, so all of these are regular because every side is the same and every angle inside is the same. When working with polygons, we can name polygons by listing the consecutive vertices in order. For example, if I wanted, I could start at the letter C to name this, and I work my way around either direction. So if I start at C, I can name this as polygon CHIMP, or polygon chimp. Now I would not have to start at C, I could start maybe here at H, and then work my way around. If I started at H, we would name this as polygon HIMPC. So we can start at any vertex and work my way around, and I can go in either direction as well. So if I start here at letter C, I would not have to go clockwise, I could go counterclockwise. So I can call this polygon CPMIH. So there's many different ways that you can name this particular polygon. The only thing that would not work is if you're jumping around to different vertices. So for example, what would not work would be C, and then I, and then MPH, something like that, because you're not going in order, you are jumping over here to the I, and then doing the M, P, and H. So this would not work. So as long as you're starting at a point and then going in either direction, we can name this polygon any of these different ways. Now let's take a moment and talk about triangles. So triangles, by definition, are polygons with 3 sides. So here we have triangle ABC. And we have a term called the vertex. Vertex can go for any polygon, not just triangles, but a vertex is each point on the polygon. So here we see point A, point B, and point C. So those 3 points are my vertices. So vertex is singular, I would say vertices as plural. Alright, and then the sides would be these different line segments. So we have segment AB, segment BC, and then segment AC. Those are my sides. And then within the triangle and any polygon, I have different angles. So in this particular triangle, we have angle ABC, which is right here. We would have angle BCA, which would be right here, BCA. And then we have angle BAC, which would be right here. And again, remember that this middle letter is going to be the vertex of that particular angle. Now with the triangle, if you look at the angles of the triangle, here we have this angle, and this angle. With any triangle, if you add all 3 angles together, the sum will equal 180 degrees. For example, if the measure of angle A is 60 degrees, so this is 60, and then measure of angle B right here is 80 degrees, I know that this third angle, angle C, would have to add with 80 and 60 to get 180. Well, 80 plus 60 is 140, and if there's 180 degrees in a triangle, we can find angle C by taking 180 minus 40, and that gives me 40 degrees. So angle C right here would have to be 40 degrees. Also with triangles, there are different ways you can categorize. The first is by side length, and the second is by angle measure. So let's begin with the angle measure first. So with angle measure, we have what is called an acute triangle. An acute triangle, by definition, has 3 acute angles. So a triangle like this would be acute, because all 3 angles are acute angles, meaning the angles are less than 90 degrees. A second type of triangle is a right triangle, which by definition has 1 right angle. So for example, this triangle would be a right triangle because we have 1 right angle right here. Next we have an obtuse triangle, which by definition has 1 obtuse angle. So this triangle would be obtuse because we have 1 obtuse angle. And remember, obtuse angles are angles that are bigger than 90. So because this one angle right here is bigger than 90, the triangle is considered an obtuse triangle. And then lastly, based on the angle measures, we have what is called an equiangular triangle, where each angle is the same or equal. So for example, right here would be an equiangular triangle because each angle is the same measure. And by the way, if each angle is the same measure and we know there are 180 degrees total in a triangle. That means each angle needs to be 60 degrees. So an equiangular triangle has angle measures of 60 degrees. Now we can categorize triangles based on the side lengths. So for example, we have what is called a scalene triangle, which says that no sides are congruent. So for example, right here, we have a triangle with 3 different side lengths. So therefore, this is scalene. Isosceles triangle has at least 2 sides that are congruent. So for example, right here, we have the left and right side being the same measure. So because these are the same length, we would say that this is isosceles. Thirdly, we have an equilateral triangle, which says that all sides are congruent. So if every side is the same, we would say that the triangle is equilateral. So we've discussed triangles. Next, we're going to work with quadrilaterals. First, we have what is called a trapezoid. Trapezoid is a shape that has one set of parallel sides. So for example, right here, we would have a trapezoid because the top and the bottom are parallel. So this would be a trapezoid. Now a parallelogram has 2 sets of parallel sides. So here we have the top and the bottom are parallel, and the left and the right are parallel. So this would be a parallelogram. Now let's take a look at parallelograms more specifically. With parallelograms, we have different types of parallelograms. The first is a rectangle. A rectangle, by definition, is a quadrilateral with 4 right angles. So here we see 2 different pictures, and both of which are rectangles. So the first one is more of what people think of when they think of a rectangle. The second shape is a square, but it's also a rectangle because a rectangle and a square both have 4 right angles. So a square is a form of rectangle. Next is a rhombus. A rhombus is a quadrilateral with 4 congruent sides. So here, both of these shapes, we see that all the sides are the same. So the first shape is what people typically think of when they think of a rhombus. But the second shape, which is a square, is also a rhombus because a square and a rhombus both have equal side lengths. Now lastly, we have a square. And a square, by definition, is a quadrilateral with 4 right angles and 4 congruent sides. So if it is a rectangle and a rhombus, it would be a square. So right here is our picture. We have 4 equal side lengths, and each angle is 90 degrees. So therefore, this would be a square. So every square is also a rectangle, rhombus, and a parallelogram. Another term is a word called a diagonal. A diagonal is a segment joining 2 non-consecutive vertices. So for example, if I had this shape right here, a diagonal would go from one vertex across to the other vertex. All right, that would be a diagonal. And this term is important as we work with different polygons. So right here we see 4 different polygons. And our objective is to determine the interior angle measure. And I should say, by the way, that each of these polygons are regular, meaning that every side is the same and every angle is the same. All right, so when we are trying to find the interior angle measure, what we're trying to find is the measure of the angles inside of each shape. So looking here at the quadrilateral, we have 4 sides. If we draw a diagonal, here we now have created 2 different triangles, right? We have 2 triangles created in there, one on the top, one on the bottom. We learned in this video that a triangle has 180 degrees. So I have 2 triangles created, and each of them have 180 degrees. So if I take 2 times 180, that will give me 360 degrees total as the sum of all these angles. So if I add this angle, this angle, this angle, and this angle all together, that would add to give me 360 degrees. Now what about a pentagon? So with a pentagon, we have 5 sides. We can create 2 different diagonals like this. So what we've done is we've created 3 different triangles. So each triangle, we said, has 180 degrees. So if I take 3 times 180, that gives me 540 degrees. So that means if I add all these angles together, so all the angles of the pentagon, they would add up to equal 540 degrees. So look for the pattern as we continue on. So hexagon has 6 sides, and if we create different diagonals, we would have 4 different triangles created. So we have 4 triangles created. Each triangle is 180 degrees. I do 4 times 180 to get 720 degrees. So if I add all these angles together, this one, here, 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 and here, all together, the sum of those angles would equal 720 degrees. Now heptagon has 7 sides. If we create diagonals from this vertex right here, we would have created 1, 2, 3, 4, 5 different triangles. So we have 5 triangles, and each triangle has 180 degrees. So if I do 5 times 180, that's going to give me 900 degrees for my angle measures. So what that means is that if I add every angle together on the inside, that sum would equal 900 degrees. So notice the pattern. For every polygon, to find the sum of the angle measures, so to find this number here at the bottom, what I do is I take the number of sides, subtract 2 to determine the number of triangles. So like 5 minus 2 is 3, 6 minus 2 is 4, 7 minus 2 is 5. So I take the number of sides, subtract 2, that's the number of triangles. And then I take that number and multiply it by 180, and that's going to give me the angle sum measure. So right here is a formula I can use to find the interior angle measure of any polygon, and this is the sum. So the sum of the interior angle measures of any polygon. So for any polygon, I can use this formula. So not only with the 4, 5, 6, or 7-sided polygon, but I can use this for maybe, let's say, a 102-sided polygon. If you had a 102-sided polygon, which is crazy, you probably would not see that really in real life, but let's say we had a polygon with 102 sides. And our question is, what is the sum of the angle measures? Well, what I can do is plug in 102 for the number of sides. So 102 minus 2 times 180. So you'd have 100 times 180, which would give me 180. Then with 2 zeros at the end, that means the sum of the angle measures would be 18,000 degrees. All right, so that's kind of an absurd illustration, but the point is I can find the sum of the interior angle measures by using this formula. And this formula came by looking at the pattern that we derived from these different shapes. And that concludes our lesson for today. We will see you next time.